Hello everyone, today we'll be working on number 89 of the heating curves problem in the thermochemistry homework problems. How many kilojoules are needed to warm up 72 grams of ice from -2 degrees Celsius and then melt it? So in order to help us, I'm going to be graphing a heating curve graph. And that graphs the temperature over time. So the ice starts at an initial temperature of -2 degrees Celsius. In order to start melting it, we'll first have to raise the temperature of the ice to 0 degrees Celsius. And then in the process of melting, it stays at a constant temperature of 0 degrees Celsius. And we see from the graph that there's two segments. The first segment, I'll call it Q1. And the heat is calculated by the mass times the specific heat of ice times the change in temperature. The second segment, which is over here, Q2, or the amount of heat needed, is calculated by the number of moles times the heat of fusion. And we use the heat of fusion because it's changing from a solid to a liquid. So I'm going to go ahead and calculate these values. So Q1 equals mc delta T. And the mass, we're given that it's 72 grams. The specific heat of ice, let's go up here to this table. Specific heat of ice, that's 2.09 joules per grams times degrees Celsius. And then for delta T, which is the change in temperature, that's calculated by the final temperature minus the initial temperature. And we want our final temperature to be 0 degrees Celsius. So 0 degrees Celsius minus, and we started at an initial temperature of -2 degrees Celsius. So minus -2 degrees Celsius. That just means that delta T is 2 degrees Celsius. So delta T would be 2 degrees Celsius. And then I'm going to get my calculator and calculate Q1. That's 72 times 2.09 times 2. We get that's 300.96. And then for the units, the grams cancel out, degrees Celsius cancel out, and we're left with joules. So Q1 is equal to 300.96 joules. Now I'm going to calculate Q2. Q2 equals number of moles times the heat of fusion. We want the number of moles, but the problem gives us the mass. So 72 grams times, and then in 1 mole of H2O, there's 18 grams. The grams cancel out, and then 72 divided by 18, that's 4 moles. And this would be our N. So Q2 equals 4 moles of ice. And for the heat of fusion, we go up. Heat of fusion of water, that's 6.01 kilojoules per mole. So 6.01 kilojoules per mole. The moles cancel out. So Q2 equals 4 times 6.01. That's 24.04 kilojoules. Now, in order to find the total amount of heat needed, we'll just have to add Q1 and Q2. But be careful because the problem asks us for kilojoules. And so Q2 is fine because that's automatically in kilojoules, but Q1 is in joules. So for these types of problems, just watch out for the units, because over here they give you the specific heat in joules, and then for the heat of fusion, they gave it to in kilojoules. So what I'm gonna do is turn this into kilojoules. So this is just basically Q1 equals 0.3. I'm gonna stop at O, and then kilojoules, and then Q total is calculated by Q1 plus Q2 0.30 kilojoules plus 24.04 kilojoules, and then we get that Q total, the total amount of heat, is 24.34 kilojoules, and that is your final answer.